This is Phil with Moose Laser Welding, a division of Quema Ag in Rock Valley, Iowa. Today I would like to talk about fit up and the proper fit up between the parts to be welded for laser welding. That fit up is crucial to a good metallurgical bond weld. A good fit up allows us to get deep penetration. A bad fit up will have gaps in the weld. So what we'd like to talk about is what kind of tolerances are acceptable. For example, I have here a laser cut 1/4 inch piece of steel with a bushing, a CNC machine bushing, that we laser weld together. The fit up between these needs to be very nice. What we've done here is we've taken this laser cut bushing, ran a drill through it to clean it up. As you know, laser cutting may have a taper or a start and a stop or a lead in or a lead out. To remove that, and we have a nice plus or minus 0.010 fit up that produces a very nice weld. As evidence here, it's a nice sealed weld with good penetration, no gaps, all dependent on the fit up. When we're welding two flat pieces of steel together, a nice, what we would commonly call a butt weld, we will use clamps to press the two pieces together, but they depend on straightness of the parts for a nice, good fit up along the whole seam. As you can see here on this part, we've done a very nice joint weld and the fit up is just right. And on this side, we've done a very nice joint weld and the fit up is appropriate. So straightness of the sub parts and clamping pressure brings them together for a nice fit up. Moving on to an aluminum part here. You can see here we are laser welding two aluminum parts together. This is some sort of door, I suspect, with some sort of door open and closing apparatus. We take the two laser cut pieces, lay them in our fixture, and we put a clamp on the top here so that we have 100% contact between the parent and the sub part. Lays down a beautiful weld and nice penetration and no bleed through and no gaps. Once again, that fit up is very important. I don't have the sub pieces for this part, but here on the finished part, I can show you, I call it a whiz flange nut, welded to a laser cut, a piece of 10 gauge it appears. Beautiful weld, we're welding from the top. Once again, we place this whiz nut down and we hold it in place with a clamp and we weld right around it. The proper fit up gives us a very nice, deep, full penetration weld. You can see here, the fit up produces a nice deep weld. We're getting about 3 millimeters of depth penetration. And that is the sub part from this pin weldment where we weld full penetration all the way around. This is a very nice fit up because both the male and the female parts are CNC machined. The fit up is plus or minus 0.005. It's a beautiful application. This is a very common laser welding application where we have a CNC machined pin or a tube which needs a cap or a washer welded on the top. Here we merely are making a circular weld, nice penetration, and the fit up between the CNC machine part and the laser cut cap needs to be nice, tight, and clean. We like to see plus or minus 0.005. While I was out in the plant this morning, I seen the guys were running on one of the laser welders, a very beautiful laser cladding job. I'd like to show this to you. Here it's a piece of CNC machined on all sides. It's a wear bar of some sort. I suspect it goes in the construction or mining or agricultural industry. And that wear bar, the guys are using the lasers to lay down a laser clad coating on the edge surface where I suspect the wear occurs to prevent wear and extend the life of these parts. And they're doing it on both sides, as you can see, top and bottom, so the part can be flipped over halfway through its useful life. And this is a laser clad tungsten carbide coating. which extends the wear life and provides a Rockwell hardness of around 65 to 67 in this application. Once again, at Moose Laser Weld, we look forward to working with you. Please send us a digital picture or a blueprint of your project, and we will give you a quick evaluation if it's applicable for laser welding. Laser welding saves time, saves money, and is good for the environment because it's very energy efficient. Thank you, Phil Koima.